A very pleasant morning, my dear friends and students. I hope you are all doing very well. So, this is your tutor Siddharth from IIT Roorkee. I am doing my BSMS Physics and currently a student of fourth year. So, I would love to teach you a very important topic for today's class. So, the topic of our class is TIR. So, what basically is TIR? TIR stands for Total Internal Reflection. You probably have been seeing a very different applications around you which uses total internal reflection as the basic application or the basic principle. For example, the mirages which you observe in desert. Okay, the binoculars which you use to look distant object, endoscopes. These are few of the examples which which includes total internal reflection as the basic principle. And other applications could be optical fiber. Right. So the optical fibers are those devices which are basis for the transformation on the transmission of optical signals at a very fast speed, at a very fast pace. Right. So before starting the topic of TIR, we should have a basic knowledge about refractive index. So what basically refractive index mean? So refractive index is nothing but a measure of how the light or any wave would travel travel through a medium, right, of a medium. Which is basically represented by eta, which is equals to the speed in that medium divided by the speed of light in vacuum, right. Okay, so let's directly jump into our topic. So let us consider two medium. So one is optically rarer medium. Let's say this is optically denser medium represented by N2 refractive index, and this is N1, and let's say N1 is a optically rarer medium. Optically rarer medium, which means N1 is smaller than N2. So let us say let us consider a source of light right here in the denser medium. So this is denser medium. So a ray would, and we all know, due to the, so this is the source of radiation, right? So, source of light. So as a ray of light would be incident on the surface of the surface of the material where rarer medium and denser medium is separated, it would try to escape from the surface, which is known as the refraction part. So, and as we all know that when a radiation moves from a optically rarer medium or from optically denser medium to a rarer medium, it tends to bend away from the normal. So this is our normal, right? This is our normal. and this was the basic path of the ray, and it would tend to move away from the normal. So this would be the shape. So this is the angle of incidence and this is the angle of reflection, right? Similarly, it would similarly let's take an another ray at different angle of incidence. So this was our source, right? So these are few cases, right? Just have a look. Now you probably be noticing few things. So what you are noticing right here, you are noticing that the reflection angle of reflection is getting increased gradually, and at a point where the angle of reflections become equals to 90 degree. This is known as the critical angle. So at this angle, the ray becomes flattened around the surface of the interface where rarer medium and denser medium is separated, right? So for any angle any angle greater than critical angle, the wave would be reflected back into the same medium. This process is known as total internal reflection. Let's say it get extended to here. So the ray would be reflected back into the same medium, right? So this process is known as total internal reflection. So total internal reflection is nothing but bouncing back of this light in the same medium when it travels from a denser to a rarer medium and the angle is greater than the critical angle, right? So this is the basic definition of TIR. So how TIR help us in different application? For example, optical medium. For example, we discussed few examples such as optical fibers. So what optical fiber does is there are two mediums of the layers, and the interior one having refractive index greater than the outer one, makes it a perfect combination of material having different refractive index, making it possible to ray travel within the optical fiber, right? So what it enables us? It enables us to travel the signal at a very fast pace, right? It takes nanosecond and fractions of second to transmit optical signal from one place to another place. I hope you would have understood this topic in a very well manner. Thank you.